All right, here we are, section 9.3, rotations. In geometry, a rotation is a transformation that turns or rotates an object about a specific point through a specific degrees. An important thing to understand about rotations is that rotations preserve distance, angle measures, and orientation of figures. That simply means that through the process of a rotation, the object does not change shape or size. So, vocabulary for this section, we have the word rotation, and then we need to talk about what a center of rotation is. That's the point that the object rotates about. And then the angle of rotation, that's how far or what degrees the object rotates. So if we look at this figure, triangle ABC, and we want to rotate this triangle about our center of rotation, which is going to be point P. And in this example, we're going to rotate our triangle in a 90-degree rotation about point P. And one thing to note that in our book, unless otherwise stated, rotations are always going to be considered counterclockwise. And so either it's not stated, or we can use the word counterclockwise or the abbreviation for counterclockwise. So to complete this rotation, we need to take each point. So we need to start with point A, and we make a 90-degree angle from point A, and then we're going to find this distance here, and then translate that point A over where it would be over here. So again, point A is going to get rotated 90 degrees to right there. And I don't have the other lines shown here, but if we did a perpendicular through B, it would look like this, and notice this distance is the same as this distance, and point C would be this line, perpendicular, would go through here. So we could look at that point B through here, perpendicular, and this distance here would be equal to this distance. And point C, if we went 90 degrees, and then we looked at this distance here, it's going to equal to this distance here, and then we could plot point C. Here we can look at our key concept, rotation about a point. And it says a rotation of x degrees, so x degrees is our angle of rotation, about a point Q, which is our center of rotation, it's a transformation that has the following properties. The image of Q is itself. That means your point of rotation, the image is also going to be the same point, since it's rotating about that point. And then for any other point, that's rotation, the distance from Q to that point, so in other words, the Q to V, is going to be equal to from Q to the image. So those distances would be the same. And the measure of this angle between a point and its image with the center of rotation is going to be that x degrees, and that could be the true for any. So if I was to take W and make this angle to W prime, that would also be x degrees. Let's look at our notation for a rotation. This book does a rotation. It uses a lowercase r for rotation. That's so we don't get it confused with the reflection. Remember, a reflection uses a capital R. So for rotation, we use a lowercase r. Then in parentheses, we have our angle of rotation and our center of rotation, end the parentheses, so that goes with, that says that we're having a rotation. Then we have in parentheses here what we are rotating. And in this case, example up here, we're rotating triangle UVW, and that's going to give us, or equal to, our image of U prime, triangle U prime, V prime, W prime. Now you're going to find that mostly in our book we are going to be doing rotations in the coordinate plane, and most often those rotations are going to be at 90 degrees, 180, 270, or 360 degrees. One way we can look at this is by first just looking at the coordinate plane and realizing what positive or negative values we have in our different quadrants. So over here in quadrant 1, notice in quadrant 1, both x's and y's are positive. So we have plus plus. Every coordinate in quadrant 1 is a plus plus. In quadrant 2, our x's are negative, but then our y's are positive. So we have a negative and then a plus. In quadrant 3, both x's and y's are both negative. So every point in quadrant 3 is going to be a negative negative. And in quadrant 4, our x is positive and our y is negative. So x is positive, y is negative. Therefore, if we know which quadrant we're going to be landing in, our image after a rotation, if we know which quadrant we're going to be landing in, then we can at least get the signs correct for each of those points. So let's look at this key concept. This is whenever we're rotating the coordinate plane, and if we're doing a rotation of 90, 180, 270, and 360 degrees, we can look at what happens. So right here, this first example is we're rotating a 90-degree rotation about O, that stands for the origin, and in this example we have the point G, which is coordinates 2, 3. So first of all, to think if we're doing a 90-degree rotation, that's just going to move us to this left to quadrant 2. So we are in quadrant 1. After a 90-degree rotation, we're going to be in quadrant 2. And also notice that the 2, 3 from point G, when we switch it over here, now we're looking at a 3, 2. So it's like we switched our x and our y coordinates. However, in quadrant 2, x's are negative. So then the x value needs to be negative 3, and the y value is going to be a positive 2. The second example is we're taking the same point, G, 2, 3, and this time we're doing a 180-degree rotation. So if you draw a line to our origin and continue it, so it's 180 degrees, we have a straight line. And now, and notice the 2, 3, it's still 2, 3, but the signs have both switched to negative, negative. So a 90 degrees rotation changes the 2 and the 3 position. If we went another 90 degrees, they would switch back, but they're both going to be negative because we're in quadrant 3. If we were to do another 90 degrees into quadrant 3, then the 3, 2 switch again, but this time the x value is positive, the y value is negative. And if we do a 360-degree rotation, of course, that's a complete circle. That brings us all the way back to where we started. So the 3, 2 from the 270, the 3 and the 2 are going to switch again, back to 2, 3, and in quadrant 1, everything is positive. All right, here are a couple more examples of where we're doing transformations by different increments of 90 degrees. On this first one, we're looking at a 90-degree rotation. And remember, in our book, we are always going counterclockwise. So this is a 90 degrees counterclockwise rotation. And we can look at a shortcut. A shortcut means that every xy coordinate is going to be mapped to y, the opposite of y, comma, x. So it's like we switch these two values, and we're going to change the y value from here to a negative value. So we can look at this example right here where we're doing a 90-degree rotation about the origin of the point 4, negative 5. So we're going to switch the 4 and the negative 5, and our y value at negative 5 is then going to become a positive 5, but we're going to put it in the x coordinate. So here we have our 5, and it's changed to a positive 5. It was a negative 5, and then the 4 stays a 4. Now we can look at a 180-degree rotation. With a 180-degree rotation, notice the x and the y remain x and y, but we go to the opposite of each of them. So this example, we're doing a 180-degree rotation about the origin, and we're going to stick with the point 4, negative 5. And with our 180-degree notation, notice the x and y stay in the same order, but we go to the opposites. So what was a 4 becomes a negative 4, and the negative 5 becomes a positive 5. So here is our image after a 180-degree rotation. The next 90-degree increment is 270 degrees. And with the 270 degrees, Again, the x and y are going to be switched positions, but this time the x changes signs. So our example, 270-degree rotation about the origin of the point 4, -5. We go ahead and switch the x and the y positions. And notice that the x is going to change sign. So here's our 4, so this needs to become a -4. So now we've got -5, -4. And now for our last rotation, a 360-degree rotation. Notice that x and y are going to go all the way around and end up back at x and y. So a 360-degree rotation ends up exactly the same coordinates. So a 360-degree rotation about the origin for the point 4, -5 is going to end back at 4, -5. And we end up at the same place we started. So here we have an example of a quadrilateral PQRS. PQRS has the following coordinates, and that this is going to go through a rotation of a 90-degree rotation about the origin. So we can first notice that PQRS is all in the first quadrant except point S, which is on the x-axis. So anything in the first quadrant, a 90-degree rotation, and we go counterclockwise, is going to put it in quadrant 2. So over in quadrant 2, everything will have a negative x coordinate and a positive y coordinate. So we can find P prime first. So P prime, remember, what we can do is we can switch the x and the y values when we go 90-degree change. So we switch the 1 and the 1, which is going to remain a 1 and a 1. But now, since we're in the quadrant 2, the x value has to be a -1, positive 1. So P prime should be at -1, positive 1. To find Q prime, we notice that point Q has the coordinates of 3, 3, and so over here it's going to be -3, 3. So again, we can switch the x and the y, which are both going to be 3's, but then the x value needs to be negative. So a -3, 3 would be about right here. Let's make that red. Point R is at 4, 1, so we switch the 4 and the 1 and make it a 1, 4, and we make the x coordinate negative, we get -1, 4 for R prime. So here we have our point -1, 4. And last we have S. S is on the x-axis at 3, 0. So if we go 90 degrees, 90 degrees is going to put it on the y-axis, and we switch those. Y-axis is going to be 0, 3. So here we are at 0, 3. So now we can connect those. And our figure would look like this. We could clean that up a little bit. And you can see our coordinates with the labels are S prime, P prime, Q prime, and R prime. Our second example is now we're going to rotate quadrilateral FGHI by 270 degrees about the origin. So remember, we always go counterclockwise. So 270 degrees counterclockwise would put us all the way over here. That's the same thing as going 90 degrees clockwise. So 270 degrees counterclockwise is the same as 90 degrees clockwise. So anything in quadrant 2 is going to end up in quadrant 1. Things that are in quadrant 3 will end up in quadrant 2. So F prime is going to be equal to the rotation of 270 degrees of point F, and point F -3, 2. So we're going to rewrite these, we're going to switch the orders. And since I'm going to end up in my first quadrant, whether we go 90 degrees clockwise or 270 degrees counterclockwise, in the first quadrant, both numbers will be positive. So it's going to be a 2, 3. So here we got 0.23. Next we can look at G prime. To find G prime, we're going to take point G, which is at -3, 1, and it's going to move to quadrant 2. Again, I'm just doing a clockwise rotation of 90 degrees or a counterclockwise of 270, and know that I'm going to end up in quadrant 2. So in quadrant 2, I'm going to reverse the two numbers, and in quadrant 2, the x value has to be negative. So we get g prime is going to be at negative 1, 3. So negative 1, 3. Point H is at negative 1, negative 1. So we're going to do the same thing. It's going to end up in quadrant 2. So we can rewrite the 1s. But it's going to be negative 1, positive 1. First quadrant, or the first coordinate is negative. The second coordinate is positive. So here we have our negative 1, positive 1 for H prime. And last, we can look at I prime. So I prime, well, if we look at I is at 0, 1. So if we switch those and put it 1, 0, and it's got to land up on the x-axis, so it should end up at 1, 0 right here. And now we can fill in our lines, and also our labels for the different coordinates. So there, this would be the rotation of a 270-degree rotation, that's counterclockwise, or a 90 degrees clockwise rotation. Okay, that's it for this video. Thank you for watching.